So hi all, today we will see our second program of our Gen AI lab, VTU. Yeah, so 1 second. Now, here this is the second question actually. In the previous program, the first program, we made a small mistake. It was that here I put an hyphen that shouldn't be there. So that actually caused an error. And the output part, it's quite simple. I'm just going to take Python. If you guys can see my output terminal, you just see over there. Yeah. So once I play, okay. Yeah. Where was it? Somewhere there was an error, right? Result. Oh, I didn't save it. Now I saved it. Now I'll run it. Yeah, now it will run. Now this will run actually. By the time it runs, we'll go for the second program since that's important. And one more thing, this whole thing doesn't have to be there. It's just for a reference. We have given it. It doesn't have to be. It's not compulsory to be there over there. Anyways. So now we'll go to a second program, which is this. Okay, just give me this minute. Yeah. So go here and come here. Now we'll start a second program, which is use dimension reduction, example PCRT, SNE, to visualize word embeddings for Q1, select 10 words from specific domain, example sports, technology, etc., etc., and visualize their embeddings. Now I'll explain PSA and TSNE in a very short way possible. Well, PSNE is like a linear format and TSNE is a non-linear format. What I mean by linear format is, take an example of a clustered cloud or a bunch of bees or a swarm of bees. So those are like scattered around everywhere, right? Now what a particular angle where I could place almost every piece in the same line, like something linear, okay, something like a pin in that format, linear format. If I am able to see that kind of data within the dataset, and that is PC. I mean that also provides your efficiency and also it reduces the unwanted data. Like it basically reduces the noise within the data. And coming to TSNE part, it's kind of different. It actually takes the neighboring data along with it. So let's take this like same swarm of bees. There will be one middle bee and that will start holding the other bees like this, and it goes on like a ball. It's like an overall globe or something, and it ignores something which is very far. Whichever is near to that, it holds it. Whichever is far, it just leaves it out. Same thing again here, but this time it will take more data. And it will be more clear also to understand and analyze and process it. That is the thing. Now let's come back to the first program. The first program output is here. As I told in the previous video, the first one, where is it? Yeah. So first is result vector. This is basically to tell this particular logic: king, man, and woman. So king minus man. King is basically a man. If man is removed, then there should be someone superior. That would be a woman. If it's a woman being superior, that's called as queen. So that one word queen will be here. And along with that, 5 words we have asked for the 5 similar words to queen. So king, queen, monarch, princess, and crown prince. These are the 5 words which relates to it. Now coming to the com part over here, actually it should have been computer, but I put com. So which relates to com. Com is like an end subdomain, right? So here you see it's edu, which relates to com. HTM, H3P is hyphen www, and then org or organization or something, and bay.com. Maybe it could be ebay.com also, but these 5 all relates to com, to the word called com. This is how the first program works. I hope you got it. Let's come to the second program part. Yeah. So yeah, we'll start with. We'll first have to import few modules. Again, as I told previously, import Jensen dot downloader as API, same like that. Import numpy as np. Oh wait. I didn't see this. Import numpy as np, and then let's import matplotlib. I'll tell why in matplotlib later on. This is the basic. Matplotlib is mostly used to plot graphs, to create graphs, 2D or 3D graphs. From scalerness to understand and within the given data sets within the given data set, it understands it and then process the data. That's the whole point. That's how scalar works. Again, if I'm wrong, just make me correct. But yeah, the overall part is let's see what the position later on. PCA full form I just forgot, but it's kind of analysis only. So yeah, and then say from scalar.manifold we will take take tsne. So this is the overall import part. Again, gensim downloader to download the gensim, numpy and np to create an array, and then matplotlib to create a plot graph, sklearn decomposition to take out pca from it, and sklearn manifold to take out tsne from it. And one more thing, for the commands to install, it's quite simple. If it says module not found error, then you have to put pip install. For sklearn, it's skit-learn skitlearn. If it's was it matplotlib, I guess it's matplotlib.pyplat itself, like the whole thing. It will just show you the name, of course, so you don't have to worry about that. Okay, same like pip install this, and then if it asks for gensim, no such module called gensim found, then same pip install gensim. If it asks for numpy, then pip install numpy. And this is how these 4 modules are mostly downloaded and worked on. And yeah, once you download this, you don't have to download this PC again. It's just that we have downloaded the sklearn and we're going to import this from sklearn. Got it? That's how it works. It's like basic English, not more than that. Anyways, now let's go to the code part. Same like previous code, word vectors. We'll create a word vector. Word vectors is equal to api.load. In this word to vec -google -300 words. I guess use 300, and yeah, for now it's done. Next comes is our the main part. So we'll create a variable called words. In that we'll put some tags. For now we'll just put like some 3 tags, not more than 3. Let's take it as 3. So tag 1 will be computer. In our code it was kind of lengthy, like computer, cybersecurity, AI, laptop, and etc. But you don't go to the concept. You just take the basic levels. So computer, cybersecurity, security, and then let's take machine. That's all. Oh, wait one second. The small mistake over here. I have to put double quotes between everything. Ensure that. So here, and then done. So we have a total of 3 words, not more than 3, because for a simple processing we'll take 3. And now we'll create a vector. Vectors is equal to, we'll call numpy, and we'll create an array within that. So numpy has a module function called array. We'll call array here, and we'll say to keep this in array. So word vectors. In that word vectors, put a function called word. Yes, correct? Yeah, correct. So we'll call word. Okay, let's come back. So np array, numpy.array, we'll create an array in which word vectors will be stored in word, and then for that we'll just this over here, and then for words, for word, not for words. For word, we'll put a for loop over here. For word in words. So whatever the output comes in word, which gets stored in word, that will be again sent to words. Verified in words. So like, how do I say? If it's computer, you have to search number of related things which relates to computer, and then it all fetches it out from the word vectors and stores in word. Yes, that's how it works. Like words, word vector, word, or word vector, words, and word. That's the flow, I would say. Word vectors, word, and then words, and then word. So whatever the words available in word vectors will be taken, and out of those, the filtered or the wanted words which is available in computer, cybersecurity, and machine learning will be filtered out, and in that, whichever the similar words are available, that will be stored in word, not words. Confusion is there, but that's the thing. Okay, now let's go to the next part, which is defining a function. We'll create a function called plot embeddings. So this is where we will define where the plot should be perfectly aware. Plot embeddings, and then in that vectors, we'll create a function called vectors, words, and then method. Method is equal to PC, and say why this is PC. Default it will be PC itself. I'll tell why it is wrong. And yeah, now we'll create 2 variables called reducer and reduced. Now in this we will call this PCA over here, PCA, and then we'll put n. Okay, I'll say what is n components. N components is basically to tell which dimension you want to use. So if it's a 2D, then n components is equal to 2. If it's a 3D, then n components is equal to 3. This applies for PCA, and why you are putting this again for plot impedance, to put a function, or like to define a function in this, especially like not like that. Exactly how do I say for it? So for the graph which you're going to take, for the graph you need which particular type of graph, which kind of dimension graph you need. If it's a 3D, then it will give a 3D image of something. If it's 2D, it will just give a graph with this XY coordinates, not the Z coordinate. But if it's a 3D, it will give a Z coordinate also, like X, Y, and Z. That's how it goes. That's a 3D coordinate. So 3D image, that's why. So now we'll tell PCA to put n components as 2, which means 2D. But if the method is equal to PCA, if the method is a PCA method, then this applies like if it's in PCA. If not, else we'll create another for TSNE. TSNE is another same thing only. As I told, it will group all the neighboring data available with it. Not data, the data sets which are available over there. Let's take the points. Yeah, that would be great. The index point, from the index point. So here also n components comes into place. N components is equal to 2. It's not 3D, of course. 2. Perplexity is equal to 5. What is perplexity? It is to call the number of nearby states. How much near should that be? So if there is like 5 things around, let's take it like this. So this is around this is near this is near this, this is near this. So combine all those and keep it in like this. So its perplexity is equal to 5. And the last, it's like an exception state over here. Random underscore state is equal to 42. So like for every time we try to print it, it gives the same output. I don't want it to get manipulated after a certain time. That's right. And this is there within the function itself, like within the scalar itself. So it's like pre-built. You don't have to define it again. Now we'll call reducer again. Reducer, that bracket, or no, I guess fit transformer, right? Yeah. This is to ensure whichever whether it should be a PCA or TSNE. Whichever comes, just get fit with that. It doesn't have to change like separate. Yes. Yeah. So vectors was defined over here. Same. This is the logic actually. This is the overall logic of the graph or for the graph. So whichever, if it's PCA, then go with this. If it's TSNE, then go with that. And yeah, that's how it works. And whichever is the output, whichever is going to be the resultant output, that should transform and get stored in vectors or apply with vectors. Apply with vectors would be the right term. Well, next comes is to plot the graph. Now to like design the whole graph for it. So that fixed size is equal to 8,6, which is by 8, like 8:6 basically. And then now it's like 8. 8 to 6. 6 in the YZ and 6 in the X. 6 in the X and Y in the. 8 in the Y and 6 in the X. Yeah, that's how it works. Now the next part is plot scatter. Now how this should get scattered, or like how this should get plotted. Plot scatter. We are not manually assigning where should it get scattered, but yeah, we are just saying where all it should go. 0 and then comma, right? Yeah. Yes. Yeah. Reduced to 1 comma. Okay, that should be 1 over here. And then yes, correct. Yeah. So this basically tells that at which row it should start, at which row it should start. So the row wise, if it's a matrix, like it's basically defining matrix, right? So then here it was. So this colon over here will define null state, and 0 is like start, initial. So start from this particular column, row itself. Same goes for 1. So from row, start from the first one. For the row 0, start from scratch. For the row 1, start from scratch. That's how it means. Like row starting and not like that. That's all. It's something just understand this basic logic. That's all I will say. If you need to just put a comment, I'll just see or message me. That's all. So now it's just basic for loop where I will be the index, from I it starts, and it will store whichever is there in words, that will get iterative, which means it will go back to the same logic over here and it will start applying the logic whichever we have done in this. Oh, one more thing, I have not mentioned it over here. I guess I made a mistake. And then this goes over here. For loop started. Now I'll put plot notate words reduce to I comma, I is basically index, so I comma 0, and then reduced to I comma 1, yeah, I comma, and then give comma over here, and then font size. By font size is default, it's up to your wish. So this is basically trying to keep those words within this region. Like wherever the dots are available, there you keep the words. Again, I has these 3 words. So wherever the words come, just assign it the font size is this. That's all. Like 12 is the font size. If you want, you can increase it. It doesn't have to be 12. Anyways, now let's go to the main part. Plot.title. Now this is to define the the image over there. So f of word embedding something word. That's all. Let's just give it this. It's up to you whether you want to give or you can give. If not, it's fine. And which method we'll be using, that method. And then plot show. Without plot show, it won't work. So yeah, you have to ensure that plot show is stable and yeah, it's running. I mean, it should be there. That's how it works. So yeah. Now we'll run the program. It will run this way, and then I'll just show you this. In the next video, I'll show you the output of program 2, because I've just put these 2 screens. So yeah. Anyways, this is the whole code, and yes, this is how it works. It's quite easy. Now again, I'll explain you from scratch in a very simple way. Import numpy as np. We're gonna call okay. Wait, I have to go top. Gensim loader to call gensim. Numpy, and then to numpy is to create an array within our program. Matplotlib to create that graph. sklearn, skitlearn to understand and compute the program, or yeah, that's all right now. Nice. In word vectors, we are putting in this thing called api.load. In that word to vec, we will use 300. This line is same as the previous program. Now words. In that words, we are going to add 3 words: computer, cybersecurity, machine. And now there, okay, we got the output actually. I got the output. I'll just save it out. Okay, this is a previous output anyways. I could just show you. Just give me 1 minute. I'll show you this, the output part. Turned out to capture. This is the output. This is the output as you see. Now I'll just enlarge it out. This isn't TSNE part. So this is not PCA. This is TSNE. So this basically groups out everything and it just leaves the rest of the characters. Now why these many came? Because I didn't save the program. The old previous program which I have seen, like when I deleted it, it's that had these many characters. But in the present program, I guess you will just get only 3 things. That will be computer, cybersecurity, and machine. Only these 3 will be linked. That's all. Apart from that, nothing will be there. So this is the thing. This is the code, and this is the output basically. I'll just take this over here. Yeah. And now, you see here, where was I? Now vectors will have np numpy array will create an array. Where in that array, it's like kind of I'll say. So word vectors will from word vectors will store all the things in word. And that words will be the output from words. Word will be the output of words. So it's like word vectors ka data, whichever is there will be there. The words will filter out the main words whichever we need, and it will get stored in word. That's the whole point. Now plot embeddings, we'll create a new function called plot embeddings. This is where we'll define how the graph should work. In that we'll create 3 functions and 1 method, 2 functions and 1 method, vectors, words, and then method called PCA. Now, if the reducer is a PCA, then it should be in 2D format, which is n components is equal to 2. If the method is PCA, this should apply. If the method is in TNSE, then it should go like it's 2D perplexity is 5, which means 5 overall, it should gather only 5 nearby data, and random state is equal to 42, which means like the more I iterate, the more only the same output should come, and number of times I iterate. So that's the whole thing. And now reduced is equal to reducer.fit program vectors. Now here again, you typically don't have to this is like you're calling the whole thing to adjust with any of the vectors available over there. If it's PCA, go with PCA. If it's TNSE, just go with TNSE. Now plot.figure, fig size is equal to 8,6, which is 8:6. As I told, I guess, yeah. So y-axis was 8 and x-axis is 6. That's the thing. And then plot.figure, fig size, okay, that's done. Plot.scatter, how the dot should scatter, that's how we have defined it. Just understand this logic. Plot.scatter, reduced colon comma 0, comma reduced colon comma 1. So that's the whole logic. No, that's the whole line, not the logic. Logic part you can understand it. Now for I is index where word in enumerate words. So the number of words whichever comes is stored in word. Now the real logic is coming. Now whichever words are there, see this is there, the word is specially there to plot it in the dots. So plot.annotate, annotate is to define those dots like network dot and stuff. And then yeah, the rest is same. Like words comma reduced index comma 0, reduced index comma 1, font size is 12. And yeah, plot title, plot show. This is your program 2. Program 3 will be soon coming.